Hippotenuse.
I'll be explaining projectiles, and the first thing you need to know for projectiles is to be able to resolve a vector or some velocity. So as you can see, let's say we have a velocity of 10 meters per second, and this can be broken down to a horizontal velocity and a vertical velocity. Okay, right. And if we look down here, see it forms a right angle triangle where our vertical velocity will equal to the hypotenuse times sine theta, and our adjacent and our horizontal velocity will be equal to the hypotenuse times cosine theta. It's all done by trigonometry, as you can see. So in this instance, say we had an angle of 30 degrees, our horizontal component will be equal to 10 cosine 30, and our vertical component will be 10 sine 30. And these are both accelerations, but this is the acceleration going horizontal, this is the acceleration going upwards. So when you put them together, you still get our original velocity. This is needed for projectile motion. As you can see here, right, you have a vertical velocity going upwards, and you also got your horizontal velocity. As time goes on, as the ball reaches its maximum height, the velocity, the vertical velocity, will decrease over time. This is because a component of gravity, the acceleration of gravity, is acting in the opposite direction of velocity. So once the ball reaches its maximum height, it will no longer have a vertical velocity because it won't be going any higher because at its maximum height. So it only have a horizontal component. And when it starts to fall down again, velocity is going in the same direction, as you can see. Velocity is going in the same direction as your acceleration. So our vertical velocity will increase over time. And as you can see here, our horizontal velocity is staying the same throughout the projectile. This is because we're assuming that there's no air resistance. This means there's no acceleration in the horizontal component, as acceleration due to gravity is only vertical. And now to set up your Suvat equations, there'll be a few instances. So from A to C, your Suvat equation should look like this. So you should have your horizontal, which is your v cosine theta, and your horizontal velocity will stay the same. That means your initial and final velocity will be the same. Acceleration will be 0 because there's no acceleration in the horizontal axis. And then for the vertical, your initial velocity will be v sine theta, and your final velocity is minus v sine theta. You can assume this if the ball, right, where it started, and it lands in the same axis, right? So it lands on the same line. So if the ball, right, if the American football landed, let's say up here, because they're not in the same line, you cannot assume they will be the minus v sine theta. It's only if they land on the same line. Okay, and the reason why it's minus sine theta is simply because it's going the opposite direction. Our velocity is now going downwards over here, where it was going upwards over here. Another instance could be from A to B, so that's from A to the maximum height. Our horizontal velocity still stays the same, but it's our vertical that changes. Where our final velocity will now be 0, because as I mentioned before, at the maximum height, the ball will no longer go vertically, so there's no vertical velocity. Gravity is still g, and the time this time, the time would be half the time of going from A to C. Okay, that's because going from A to B, the time taken from A to B is equal to the time taken from B to C. That's what you got to know for projectiles. Okay, so question 7: a particle is launched from point A on a horizontal surface with a velocity of 22.4 meters per second at an angle theta above the horizontal as shown in the diagram. After 2 seconds, the particle reaches the point C, where it has the maximum height above the surface. and it says show that sine theta is equal to 0.875. So since they want us to show sine theta, we know that it must be in our vertical axis. Vertical, right? So we can do SUVAT for our vertical. SUVAT. We want to show reaches its maximum height. So at maximum height, our final velocity will be 0. Our time to get to our maximum height is 2 seconds. Acceleration is always 9.81. Our initial velocity would be 22.4 sine theta, and we don't know our maximum height. So based on this, we can use the equation A is equal to V minus U over T. This will give us, if you rearrange it, you get sine theta is equal to 0.875. Okay, so the first question is pretty easy. The next bit is find the height at point C above the horizontal surface. So we want to find basically this maximum height now, right? So we can still use our vertical component that we did before. We can still use the same SUVAT that we had before. However, this time we got the same SUVAT equation, the same SUVAT thing. And this time, instead of using this time we've got to use this equation, the v squared minus u squared equals to 2as. We're solving for the distance, so we can rearrange it to get v squared minus u squared over 2a is equal to s. Plug in our values. And now, if you put this in the calculator, you get distance of 19.6 meters. Okay. The next bit of the question, part C, the particle returns to the surface at point B. Find the distance between A and B. So this time we want to find the horizontal distance between A and B. And we know from before, right? We know that sine theta is equal to 0.875. If you do inverse sine, right, we can do inverse sine to give us, it will be around 61 degrees. Draw our horizontal SUVAT. We want to find horizontal distance. We're given our initial distance, which is 22.4 cos 61. 22.4. Acceleration is 0, and time this time. Okay, so it's given that time is 2 seconds from A to C. So from A to B, it'll be 2 times 2. Because the time from here to here, the same from the time from here to here. So time would be actually 4 seconds. Okay. So now we can use equation. Speed is equal to distance divided by time. Velocity is 22.4 cos 61 times by 4 is equal to distance. Distance is equal to, should get 43.3 meters. That's part C done. Next part, part D. Find the length of time during which the height of the particle is above the surface that's greater than 5 meters. So what this is asking for, let me just erase this real quick. So there'll be at this point here, and at this point here, there'll be 5 meters high, right? 5 meters high. We want to find the time at these 2 points. We want to find the time at these 2 points. So what we can do, right? We can use our vertical Let's do that. And we want our height to be greater than 5, so we can put in 5. Right, and we want to find a time. We want to find a time when our distance is greater than 5, so we can put time as t. Now we can use the equation s is equal to ut plus 1 over 2 at squared, because we want to find a time, right? We've got everything else. Now you plug in our values. And now that you have this expression, you can put this in your calculator and it'll give you two values of t. The two values of t should be equal to 0.27 and t is equal to 3.65. Right? So if we look back on our question, so our time, when time is t is equal to 0.27 and when t is equal to 3.65, the height would be greater than 5 at these 2 points. So the time between 0.27 seconds and between 3.65 seconds, the projectile will be above 5 meters, so it's all from here. Right. So now we can write the inequality that 0.27 is, the time is between 0.27 and between 3.65. And this is when our projectile is above 5 meters. And the last question. Right, so this is testing a theory. Okay, so question E now asks, find the minimum speed of the particle. The minimum speed of the particle will be at point C. This is because at this point C, there's only a horizontal component of velocity and there is no vertical component of velocity. So from our previous questions before, part E, to find our horizontal component of velocity, it would be 22.4 times cosine theta. Previously, we got theta is equal to about 61 degrees. So we plug that in and we get about 10.9 meters per second. That's our minimum speed. Right, and that's it.